Hi everybody. In this video I'm going to explain to you how to use MATLAB to find the first or the sum of the first 10 terms in Fourier series of an signal. This signal that we explained in previous video, how can you find the coefficient, all right? And I'm going to continue in the same example. First, you look at the waveform and check if there's any symmetry, and as we explained previously, that's an even function, all right? So that's an even function, and since it's an even function, you will know that bk is equal 0. Accordingly, we are going to find a0 and ak and then find the series. Well, secondly, you got to check the period, and we explain also that the period it's equal 4. You can see it's from minus 2 to minus 2s to plus 2, that's 4. So it's 4 seconds. And the frequency or the fundamental frequency of this waveform is calculated as 2 pi over t. And since t is equal 4, so it will be 2 pi over 4, which is pi over 2. Now, how can you find the first 10 terms? Well, remember that bk is equal 0, and you have a0 and ak. Sometimes you can find a0 is equal 0, sometimes not. So it's not, so that's, the equation for even function. It will have only two terms, a0 and the sum of the ak cosine. So that's why they call even function cosine terms. So we need to find the first 10 terms. What does it mean? It means that's one term, and then you want to find another 9 terms, like a1 cosine omega t plus a2 cosine 2 omega t, and so on, by calculating also the value of omega naughts. Well, that's the equation for a0, and that's the equation for ak, and we already know that bk is equal 0. So how are we going to program it in MATLAB? We'll go here from MATLAB. As we know, the first statement you write clear, so you clear the memory from any calculation or anything stored in the memory to make sure that when you run the program, many times it will not be affected by previous results. Secondly, here we just write the statement for the period is equal 4 seconds, as we explained, and we calculated here the fundamental frequency, which corresponding to the equation omega naught equal 2 pi over t. I did just the same thing, all right? So it's just calculated. So, and then you will say that since t space k, it means that the MATLAB is going to look for t and k as symbols, all right? It will be treated as symbol. Well, then we go, that's the expression for a0. How we write this a0? Well, if you go to the equation, you'll find that a0 is equal to 2 over t, the integration from 0 to t over 2 x of t dt. So t over 2, that's t over 2, times the integration, you use, code int, it means integration, and then you have the bracket. Listen now very carefully. The first one here, right? This is the function where it said 1 minus half t. How we got that? If you remember from previous video, we just said that from 0 to 2, that's corresponding to t over 2. So, and the equation of this straight line, it's 1 minus 0.5 t. The slope is equal minus half, right? Time t, and this is the y-intercept one. So that's the equation. So that will be considered your x of t in the period from 0 to 2. So you'll go there. That's in the code. Very simple, direct. This is the x of t in the period. And then you write the variable where you do the integration, because you will learn in Fourier transform, sometimes you integrate to the omega. You are here in Fourier series, we are integrating with respect to delta t. So you put the variable t. Whatever you are integrated to, you put the variable t, and t has to be defined in sims. All right, so that's done. What about this, the last two terms? That is that's the limit of the integration, 0 to 2t. That's 0, all right, and that's t2, t over 2. And it already be calculated because t has to be defined first. So t is defined as 4. So you make sure that any variable you use you make sure it's defined first, so you will not get error. Well, now you wrote the equation, or you code the equation for A naught, or the DC term. Now we are going to write AK. Well, let's now just see how you write AK. Let's just have now AK is equal to 4 over T for even, from 0 to T over 2 x of t multiplied by cosine k omega naught t, and the integration with respect to t. So that's 4 over t, the integration, that's the integration, and that's the function. Remember here the function is like a complex function here. That's xt, you have to use bracket, times, because times here, cosine k omega naught t, all right? So everything should be written here. Of course, I mean, k doesn't have a value, so it's, you define it in the sims. And omega naught has value, so you find it's calculated in the top, before sims. T does not have a value, it's going to be a variable. You want the expression to be in terms of this variable t, then it's defined in sims. So generally, when you want something that you don't substitute by value, just to be like symbolic, you have to define it in sims. Something has value, you have to put the value in it before. All right, so you are integrating with respect to delta t, so you put the variable t here. And the limit from 0 to t2, that's 0, that's t2. All right, very simple, all right? And by the way, in the handout, you'll find I have many examples explaining how to use the sims tools. Now, up to this step, we did it last time. We defined A naught and AK. Now you are going to do the sum. What do you mean by that? This is the one. Okay. So how you do the sum? Well, forget about A naught now and just let's look for the sum. For the sum, if you put 10 terms here, it means you're going to add 10 terms. So you say from 1 up to 10 and you increase it by 1. So it'll be like 1, 2, 3, 4, because you are increasing by 1, and you should do that. All right. So you make for loop, all right, for loop, and you write the expression of the sigma. What's sigma inside? This is the expression. AK times cosine k omega t. All right. Let me write down here. Let's just, not to confuse you. So that's the x of t will be equal A naught plus sigma from n equal 1 to infinity. Let's say 10. Now we are going to make 11 terms. I will just show you now. Then AK times cosine k omega naught t. So AK has to be defined. You have AK here, all right? You did it. You just copy, you copy here, or the result, whatever the result. Because if you run the program, previous program, and to find the AK, it gives you the result. Because this is not the result. This is the expression. If you run the first program, it will give you the result, and this is the result. I just copy the result. So please review the last program. Because if you run the program before you write this expression from here, if you just stop here, you can do that. You stop. You don't type anything. Run the program. Get the result. It will give you AK. Just copy and paste AK here. And then it change K to N. So we'll have a N. For sine pi, it was K there. Put it N. Because you are using here for N. You are making the loop N, not K. Not confuse them. The same thing. This is the same result. Just please check the previous video and the program. You just copy and paste the coefficient here, and it change K to N. And make sure you have N from 1 to 10 here. All right. Forget about this now. I just don't want to confuse you. So this is A. All right. So just to be on the same pace, we'll say this one would change it to AN. And this one to N, cosine N omega naught. All right. So you type this in, all right? So, and you come here and you see Fy equal Fy plus An, this is the expression here, An times cosine n omega naught t, this the same term here. So what you are doing here, this is like, I mean, you have here like a container, and then the container has inside An. If there's nothing there, it was zero, right? It was zero. Now, when you start to calculate the first n1, it will calculate a1 times cosine 1 times omega t, and then put it there. So you got here the first term, all right? You got the first term. Then it will come and end, and then it will go for the for loop, and then go to the second value, n equal 2. It will start to calculate, but what is going to put Fy? It said Fy is equal Fy plus this term. So this Fy, the previous value, and this one, the updated value, or present value now. So when we start this loop, and this assume that was 0, so we'll put 0 here, plus, and then calculate n equal 1, you got this term, and you put it there. That's now your Fy. When it comes to the end, it go there, it will find out that still numbers to calculate, so it will put n equal 2, so it will go down. So it was Fy, it's our Fy previous, which was 1 before here, so it put here the first element, let's say that we'll put Fy1, and then n2, it will calculate second element, and then add this one to the previous one and put it there in the container. Finish end, go to the loop again. Now n is equal 3, it will go down. Fy previous, now it was the sum of the other two terms. The sum of the other two terms. So, now n is equal 3, it put a 3 plus cosine 3 times omega, so they had, and then add it to Fy, and put it there. Now you have Fy, F1 plus F2 plus F3, and then you go to the end, go back again. Now n is equal 4, it goes down. Fy previous, it was all these three terms, and then it calculated the 4, and so on. That's how you make, like, I mean, the container, you are adding every time new term, you calculate till you finish 10, then you are done with the sum. Up to this, that's it. I mean, if you print it, you get the result. But now there is something, you know. I said that we are going to start to put Fy is equal 0. But we are not going to put 0. We are going to put in Fy in the beginning this value. So you come here, before you do the sum, but Fy is equal a naught. So this container was not empty. No, it had a naught. So when it starts with n equal 1, this one already was defined here has a naught, and then it calculate n1, and then start to do the process I just explained. So now a naught is added to the sum. So the sum is done by the for loop, and anything initial, if it was something here, you put it before the sum. Now we did everything here. Now let's just do some modification to this program, because I want to understand every single line. So you are done with the calculation and the sum, but there are certain things you got to understand. When you print out the program without doing this extra thing in the middle that I didn't explain it yet, you will find you have big numbers and small numbers. You find numbers, just please do it before you do that. You'll find some numbers multiplied by e minus 33. It means 10 to the power minus 33. Because in MATLAB, they are calculating every single thing. So even the small number is not going to be printed 0. It will be like 10 to the power minus 33 or minus 32, huge number. So to avoid printing these small, very small numbers, you make this condition. He said what he said. If an less than 1 over 10,000, that means it's really very small. So I said ignore it, put it 0. Put an is equal 0. In this way, you're avoiding any very, very small number. If you didn't do that, it will print them. And then after that, by your hand, you can delete it. you will see it's just very small. But I mean, why do that? Just make the program, the MATLAB do it for you. So now we are comparing an, the coefficient. If it is very small, you make it 10,000. So you put it 0. That will guarantee that you avoid any, because even the calculation was right and the coefficient is really very small, it will be insignificant. So delete it. So this condition, every time it calculates an, it will go here. It picks n equal 1 or 2 or 3, whatever. Calculate an, then it comes to the condition. Is a1 is really very small, less than 1 over 10,000? If it's yes, put in 0. If it's not, it will just jump from. It will not pass by this. It will just come here and print it and put it there. Okay, so this one just to avoid any small number. Very small number, any very small number, not just, small number. No, very, very small. Neglect. Now, if you print it without doing this, you'll find the numbers in the front or the coefficient really writing like 12 digits. It will be annoying. It doesn't look nice. So use this. That's a very, very useful command. Type VPA and bracket. And this expression, it will put it there. And comma 3. What does mean 3? How many digits you want to see? How many digits in the expression you should find? So to make it, very easy for your eye to see. But you don't like to have like 12 digits, right? So that will make it very easy and simple. This command. It's nothing, just simplifying the expression. And then when you do it, you'll find the good result. Please do it. I'm going to put it in the document with the result and work this program out, because it's very useful and you're going to use it in many programs. How can you, and you can check your answer too, because it will give you just, it's a nice way to check your answer. Well, what's left now? How can you sketch this? Or if you have symbolic variables, symbolic results, how can you convert it to numerical value? That will be in another video. I hope that you understood. Please, when you have any question, just type it in the comment, please, in the video on YouTube when I publish. So I will follow you. Thank you very much.